Good morning, all. Today's topic is summarizing and standardization. So, what do you mean by summarizing? So, summarizing, we call it as data summarization. So, data summarization is nothing but a fundamental step in data science. So, whenever we are collecting a data, a raw data, and we can able to get in some actionable insights from the data summarization. So, it is a process of reducing the complexity and size of the data by extracting its main patterns, trends, and features. So by using this summarization only from the raw data, we are going to get some insights. And from this figure, we can able to understand that based on statistical operations, we can able to summarize the data as centrality, dispersion, and sample distribution. Now we'll see one by one. So first is summarizing, and in that we are focusing mainly on the centrality. So what is centrality? So centrality means it describes the center or middle value of your data set. So we have three common measures of centrality like mean, median, and mode. And we all know that mean is nothing but the average value of your data set, and we can able to calculate by summing up all the values and dividing by the number of values. And next is the mode. Mode is nothing but the most frequent value in a data set, and a data set can have only one mode. In that case, it is called as unimodal, or it can be called as multi-modes, or it can multi-modes or multimodal, or even no mode. And the last one is nothing but the median. So the middle value in a sorted data set, you call it as median. So in this case, you have the data as in a sorted manner. So and in case of median, it is less sensitive to outliers than the mean. So next comes the second part of our summarizing, which is nothing but dispersion. So dispersion is nothing but, as the name implies, this category is going to measure how spread out the data is, how the data is spread out. So, and the main common measures of dispersion are standard deviation, variance, and range. So, standard deviation, it is going to measure the spread of data around the mean, and higher a standard deviation means it has a greater variability. And then comes the variance, which is nothing but the square of the standard deviation, and it is often used in the statistical calculations. And the last one is nothing but the range. We all know that the difference between the maximum and the minimum value in a data set is called as range. So the last one is your sample distribution, which is nothing but we can able to make it by means of these four things. So first we have to understand about what is sample distribution. So sample distribution is nothing but we are going to analyze the shape and characteristics of the distribution of data. So most common methods are histogram, tally, skewness, and kurtosis. And histogram, it is nothing but a graphical representation of the distribution of a numerical data set, and it is going to show the frequency of values within certain intervals. And next comes the tally, which is nothing but it's a very simple method for counting as well as for recording data using marks. And the third one is nothing but skewness. It is going to measure the asymmetry of the distribution. So whenever we have a positive skew, it is going to indicate a longer tail to the right. Whereas when we have a negative skew, it is going to indicate a longer tail to the left. And the last one is nothing but the kurtosis. It is going to measure the tailness of the distribution. And whenever we have a high kurtosis, it is going to indicate a heavy tail distribution with more extreme values. So then we have the standardization. Standardization is nothing but it is again a common pre-processing technique in data science, and it is whenever we use this technique, we are transforming a numerical data to have a mean of 0 and a standard deviation of 1. So it is particularly useful whenever we are dealing with features that have different scales or units, and we are going to ensure that all the features contribute equally to the model. So that is where standardization comes into picture. And why we go for the standardization? Whenever we are going to equalize feature importance, or whenever you are going to improve the model performance, or whenever we are going to have compatibility with certain algorithms, in that case we will be using this. So equalizes feature importance. That means whenever we have a feature with larger scales, it is going to dominate the model, whereas the features with smaller scales might be less influential. So what we are going to do is, whenever we use standardization, it is going to ensure that all the features contribute proportionally. And then how come the standardization is going to improve the model performance? So whenever we use machine learning algorithms, especially those based on distance or gradient based calculations, we can able to improve the model performance by using the standardization concepts, standardizing the data. And finally, compatibility with certain algorithms like k nearest neighbor or support vector machines assume this standardized data. So we have two different methods, or the most common methods are called as Z-score normalization and min-max normalization. So we'll see one by one. So the first one is called as Z-score normalization. So Z-score normalization are also called as a standardization in few terminologies, and it is a common pre-processing technique in data science where it is going to convert the numerical data to have a mean of 0 and a standard deviation of 1, and it is particularly useful when dealing with features have different scales or units, as it ensures that all the features contribute equally to the model. And the formula we go for is x minus mu by sigma. So that mu is we can represent as mean, and the standard deviation is nothing but the sigma. So x minus mu by sigma. So, and once you feed into this formula, you will be getting a normalized value, that is nothing but the z. So z is the normalized value, x is the original value what you wanted to make it normalized, and mean or mu is the mean of the data set, and standard deviation or sigma we call it as the standard deviation of the data set. So next comes the min-max normalization. So min-max normalization, so it is a technique used to scale numerical data to specific range, typically between 0 and 1. And whenever this is helpful when you want to compare different features on a common scale, or when you want your model expects data within a certain range. So how the formula for min-max normalization is x, or x scaled is equal to x minus minimum of x divided by max of x minus min of x. And x scaled is the normalized value, x is the original value, min of x is the minimum value, and max of x is the maximum value in the data set. And this min-max normalization and z-score normalization, everything, both are going to help us in case of normalizing the data. Thank you.